So, not using a microscope for this, but to try and explain what we're doing with the microscope, with trying to use stage microscopy and eyepieces. For example, here I've got my visualizer on a piece of A4 paper. If I put a pen on that piece of paper, it looks different size to a real pen. Now obviously with a microscope you will have had, by this point, you would have had, here's your stage where your pen would be on, or whatever your sample is. Let's draw a pen, very badly, a pen. You would have then had a lens, which would have magnified it by some amount. Let's go times 10. It would have then gone up, and then your eyepiece, drawn it separately, would also have a times 10 magnification. So by the time it gets to the bit where your eye sees it, it's been magnified a few times. The size has been changed. Now at key stage 3, what we then told you to do was to put a ruler next to the size of the object next to your eye to get an estimate of its size. Now if I do this close to my visualizer, okay, as you can see, that's there making my pen under 2 centimeters long. Now we know that's wrong because the pen, I'm going to put this one upside down, is longer than that. Now in an ideal world we would do this with a microscope and put a true scale ruler right next to the object we're wanting to look at. However, that involves using 2 different slides at the same time, and they'll be on different focal plane because obviously you can't have them next to each other. You'd have to have one above the other, and with a microscope they will go out of focus, so that doesn't work. But we can put a scale bar up by our eye. So what we do is we would have our real object, in my case a pen, that we wanted to work out the size of. We would then put a scale bar up. I'm going to try to get the 4 at the edge by pen, and I'm going to say my pen, a lot of moving from me, obviously in a real one it doesn't move like I am, it's about 14 units. I'm not calling it millimeters here because obviously, yes, I'm using this millimeter scale, my ruler, but we know it's not that size. What I would then do is remove my sample from the stage of the microscope. I would put a known scale bar on my microscope using the exact same 2 magnification lenses, and put my eyepiece one up again. And what I would do is, and this is what actually happens, is the eyepiece one can move around, the bottom doesn't, is I would try and line them up, and here, and the 7, to 8, it goes from, is the equivalent of going from 20 to 30. So 10 units on the upper eyepiece is equivalent of going 100 units on the stage microscopy. So this is your eyepiece graticule. Eyepiece graticule. Okay, with this one. So therefore, each eyepiece graticule is going to be whatever's on the stage divided by the eyepiece graticule. In this case, it's going to be 100 divided by 10 equals 10. Okay, my pen, for example, was 14 eyepiece graticules. So I just take the 14 of that, times it by the 10, giving me 140, and we now know that this is millimeters. given me 14 centimetres. If I grab the same pen, move this over so I'm not quite clear myself, stick it down, the pen is just about 14 centimetres, so therefore this has worked. Like I said, we're using this as a way of then working out what the real size of our object is. Now obviously the objects are a lot smaller than 14 centimetres, we're normally talking around a millimetre, but this maths holds true. Hopefully that helped explain how to use an eyepiece graticule. In class